Multimedia Publishing Incorporated of Denver, Colorado presents Problem Solving, Documentation, and Program Expansion, Lesson 3 in the Quality Assurance in Diagnostic Radiology series by Rita J. Cusworth. This audiovisual presentation should be used in conjunction with the review exercises found in your student workbook. You should now have the title frame in view and be ready to proceed with the audiovisual presentation. Remember to listen and watch carefully and write in your student workbook only when directed to do so. Number 2. In Lesson 1, the initial 3 steps of quality assurance implementation were discussed. These included selecting personnel, defining the goals of the program, and describing the responsibilities of the program personnel, implementing a reject analysis, and analyzing the results, and standardizing the technical factors. Lesson 2 covered selecting and performing quality control test measures. This lesson discusses the last 3 steps of the program. Step 6 describes taking action to accomplish corrective and preventive maintenance. Step 7 is concerned with the documentation of the quality assurance program, and Step 8 outlines what must be done to expand the program. Number 3. Upon completion of Section A of this lesson, you will be able to describe the procedures to follow when test data demonstrates that equipment is not operating within acceptable performance limits. Define troubleshooting and describe the 3 steps of a troubleshooting program. Identify the procedures included in a preventive maintenance program. And identify which preventive maintenance procedures are performed by the radiographer and which are performed by the physicist or professional service engineer. Number 4. If any of the quality control tests performed in Step 5 provide data that does not meet the established equipment specifications, then adjustments or repairs need to be made. For example, an adjustment is required if the collimator light and the X-ray beam are more than 1 centimeter out of alignment at a 40-inch target film distance. Number 5. In Step 6, we'll discuss equipment problems and repairs. In this Take Action step, we also talk about procedures to help prevent major equipment breakdowns and procedures to locate causes when breakdowns do occur. Number 6. A policy should be developed for handling problems uncovered by quality assurance tests. The following is a suggested procedure. 1. Repeat the test to validate the data found on the first test. 2. Notify the proper authority, usually the professional service engineer, regarding the problem. Be prepared to show the test results and specifications. 3. After the equipment is repaired or corrected, document the adjustments and the date they were made. 4. Retest to determine if the equipment is operating within specifications before releasing the unit for use. Then document the results of retesting for future reference. Number 7. Some minor adjustments can be made by the radiographer if proper training has been provided and if the authority to do so has been granted. One individual in each radiology facility should take a course in automatic processors and be familiar with operating, cleaning, monitoring, and adjusting the processor. This is especially helpful in busy departments with only one processor or in rural areas where service personnel are often located hours away. Minor adjustments that can be made by the radiographer include adjusting processor temperatures and replenishment levels, tightening locks, changing safe light filters or bulbs, and blocking light leaks in the darkroom. Number 8. In addition to making adjustments in the darkroom and on the processor, radiographers can save the department costly service calls if they have a thorough understanding of how their radiographic equipment operates. Troubleshooting is a process of tracing a problem, finding the cause, and taking appropriate action. A troubleshooting program can be used to handle problems with radiographic equipment. If successful, a troubleshooting program will eliminate unnecessary service calls. Number 9. Phase 1 of a troubleshooting program involves making a list of common operational problems in the radiology department. This list is gathered from interviews with the radiographers working in the department and the professional service engineers who are called to repair the equipment. As a problem is identified, you should list several solutions for that problem. In each situation, the solution should answer the question, what do I do if? Number 10. For example, let's ask the question, what should I do if the fluoro unit fails to operate? As possible solutions, first check the control panel to see if the machine is on, if the fluoro mode has been selected, and if the fluoro timer has been set. Then check the spot film device to see if it has been pulled across and latched, if the spot film cassette is in the park position, if the image intensifier is connected to the spot film device, if the KV stabilizer selection switch is in the automatic mode, and if the fluoro shutters are open. The last step is to see if the foot switch is plugged in or if there are any wires exposed in the foot switch. This checklist may vary slightly and will be determined by the make, model, and operational characteristics of the radiographic equipment being used. If the radiographer tries each solution and the fluoro still will not operate, then the radiographer in charge should be notified of the need for a service call. In other words, the radiographer has done everything he or she can. Number 11. Phase 2 of a troubleshooting program involves developing a medium to convey troubleshooting communications. The troubleshooting list can be posted in each room on a bulletin board or in another designated area, placed on 2 or 3 cards as part of the technique card file, or it can be included in the procedure manual. Before these instructions are posted, however, an in-service program should be held on the use and objectives of the troubleshooting program. Number 12. During Phase 3, each radiographer is evaluated on the use of the troubleshooting list. The quality assurance technologist, professional service engineer, physicist, or other designated individual sets up a problem situation that might be encountered on the radiographic equipment. The radiographer being evaluated is expected to solve the problem using the checklist. If the radiographer is not familiar with the material, a review will be necessary. The troubleshooting program should also become an important part of new radiographer orientation, which will be discussed in Step 8 of this presentation. Time spent familiarizing radiographers with the troubleshooting list of solutions will more than pay for itself in reduced service calls. Number 13. So far, in Step 6, we have discussed the procedures to follow if equipment is found to be out of specification by quality control test measures. We have also discussed minor adjustments that can be made by a radiographer and the use of a troubleshooting checklist if equipment doesn't work. All of these measures can be categorized as corrective maintenance that involves fixing something that is wrong. According to Bureau of Radiological Health recommendations, the maintenance program should also include preventive maintenance, which could prevent unexpected breakdowns of equipment and disruption of departmental routine. Preventive maintenance procedures should be included in all quality assurance programs. These procedures reduce equipment downtime by detecting problems before they affect the performance of the unit. These procedures are also used to protect patients and operators from electrical and mechanical hazards. Number 14. A preventive maintenance program includes inspecting electrical and mechanical components, cleaning equipment, and adjusting units that do not comply with accuracy and performance specifications. Many preventive maintenance procedures must be performed by a physicist or professional service engineer, particularly those measures that require calibration, repair, or adjustment of the unit. This is a sample checklist for a general-purpose X-ray diagnostic generator. These procedures usually involve shutting a room down for a day or more, once or twice a year. This may seem expensive and inconvenient, but the consequences of not performing preventive maintenance can be far more costly. For instance, notice on the checklist the items covering mechanical elements of the system. A piece of heavy equipment, if not secured properly, could fall and injure a patient or radiographer. Number 15. There are some helpful preventive maintenance measures that can be performed by a radiographer. Some of these measures, such as processor maintenance and cleaning, were discussed in Lesson 2. In addition, periodic walkthrough inspection should be conducted in each radiographic room, as well as an inspection of the mobile units and specialty equipment. Every 3 or 4 months, the mechanical and electrical parts of the equipment should be checked for strength, function, and safety. The radiographer should test the locks, brackets, clamps, knobs, and other hardware for security and function. The cables, especially the high-tension cables, should be inspected to ensure that they are not becoming cracked or frayed. Also, the entire room should be visually inspected for cleanliness. Number 16. The walk-through inspection should include a check of the source image receptor distance. When the X-ray tube is installed, a mark should be placed on the end of the tube housing to designate the location of the focal spot. Use a tape measure to check the distance between the focal spot mark and the tabletop or bucky. Determine if this distance is the same as the distance shown on the focal film distance gauge. Number 17. You should now be ready for Review Exercise A in your student workbook. When you have completed the exercise, turn to the answer page at the end of the Review Exercise section and check your work. Then restart the tape. Stop the tape now. You should have completed Review Exercise A and checked your answers. If your score is less than 80%, you should review this material before proceeding to Section B. A score above 80% deserves congratulations. It indicates that you are mastering the material. Number 18. Once the quality assurance program is established, much data on policies, procedures, and test results will be generated. This data must be documented and easily accessible to program participants. Otherwise, it will be difficult to analyze results, correct problems, and implement changes. Step 7 concerns gathering the factual information generated by the quality assurance program and organizing this material into a comprehensive manual. Number 19. After completing Section B, you will be able to list 2 reasons for developing a quality assurance manual. List the material that should be included in a quality assurance manual. Identify the data that should be included on test forms. And describe the importance of keeping accurate records and test films. Number 20. One reason for developing a quality assurance manual is that the manual provides a master plan for the quality assurance program. After reviewing the manual, a person should have an overall awareness of the objectives, functions, and administration of the program. The manual also provides access to information in one central location. This is particularly helpful for persons involved with the program and for surveyors visiting during the accreditation process. Number 21. The Bureau of Radiological Health Publication Quality Assurance Programs for Diagnostic Radiology Facilities recommends that the Quality Assurance Manual include the following items: the goals and objectives of the program, a list of individual duties and responsibilities, a list of tests and the testing schedule, and a description of each test procedure used in the department. Test procedure description should include a list of the test equipment and test specifications. Other items that should be included in a quality assurance manual are a list of reference materials on test procedures and quality assurance techniques, records of test results, and purchase specifications and acceptance testing records. We'll discuss purchase specifications and acceptance testing in Step 8. The Quality Assurance Committee should revise the manual at least once a year. Preparing the manual in a loose-leaf binder allows the addition of new material. Number 22. The Quality Assurance Manual contains the master plan for a successful quality assurance program, but specific data for each radiographic unit must also be recorded. One way to do this is to maintain a logbook for each radiographic unit in the facility. The logbook should contain technical specifications for the equipment, such as tube rating charts, equipment operating instructions, and detailed identification of system components. It should also include scheduled quality assurance test dates